if you substitute x as 0, 0 plus sine inverse 0 by a becomes 0, so 0. So this is completely 0. This curve represents the part of an ellipse, therefore the substitution for y must be using this relation. A is the radius of the circle. So in general, what is the area of a circle? It is pi r square, where r is the radius of circle. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are studying about the chapter Applications of Integrals, where we are going to find out the area under the curves. In our previous session, we have discussed few examples of finding areas under the curves along with the straight line. Here in this session also, we are going to find out the region bounded by the curve as well as the line. So these questions are for 5 marks in your examination. So from the chapter Applications of Integrals, we have 8 marks. So 1 3 marks and 1 5 mark question. So whatever we have discussed, very simple parabolas, that is parabola as well as its latest rectum, are area bounded by parabola and a straight line, or very simple curves like finding the area of sin x from given interval, finding the area of cos x for the given interval. They are all examples for 3 marks question. And in this session, we are going to discuss the problems of finding area under the curves along with the line, which is for 5 marks in your examination. So here is our first question. Find the area enclosed by the curves x square by a square plus y square by b square is equal to 1 by the method of integration, and hence find the area enclosed by the curve x square by 16 plus y square by 9 is equal to 1. So here I have taken an ellipse here. So this is what I have taken an ellipse. The standard equation of this ellipse is x square by a square plus y square by b square is equal to 1. Now I need to calculate the total area bounded by this ellipse. We know that ellipse is symmetrical towards its axis. So here we can say A dash is called major axis, and hence it is symmetric also. So if I find the quarter part of this and multiply by 4, I will get the total area required for this ellipse. So what I will do here, I will take the shaded portion, I will find the region of the shaded portion, and then I'll multiply by 4, then I'll get the total area covered by ellipse. So here also we can say the coordinates are from 0, 0 to a, 0, because we are differentiating with respect to x, hence coordinate must be taken with respect to x. So therefore here I need y actually. So here I have y square. So if I need y here, what happens? Y square by b square is equal to 1 minus x square by a square. And here it becomes y square b square. Here you can take a square minus x square divided by a square. Taking square root on both sides, we get here b square becomes b, a square becomes a, we can take it out outside, and here it becomes a square minus a square. So this is, after simplification, we get the value of y as b by a root of a square minus x square. Now let us differentiate applying the definite integral so that we can find the area of an ellipse. So now therefore area is 4 times. Why 4 times? Because I am only calculating the 1/4 of the area. So therefore it is 4 times, and limits are from 0 to a, y into dx. But what is y? It is 0 to a, b by a square root of a square minus x square dx. So b by a is a constant, we can take it outside. So therefore area is equal to b by a integral from 0 to a root of a square minus x square dx. So this is some special type of integral where we have learnt what is the integral of this form. So whenever the integral of the form root a square minus x square dx is given, so it is always x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. So this is the value of the integral for this value. So now let us apply the interval from 0 to a here. So now outside we have b by a. First, let us apply for a. If you apply for a, what happens? A by 2. In the place of x, you have to replace a. So a square minus a square plus a square by 2 sine inverse a by a. So this is what our first integral minus. So here, if you substitute x as 0, 0 plus sine inverse 0 by a becomes 0. So 0. So this is completely 0. Now let us solve this. It is b by a. So this term becomes 0 because a square minus a square is 0. 0 into a by 2 is 0. And here we have a square by 2. What is sine inverse a by a? So sine inverse a by a is sine inverse 1. What is sine inverse 1? It is pi by 2. So here a get cancels. So we have here b, a, and here we have pi by 4. But remember, I have taken area as 4 times the given area. So therefore, I have to multiply 4 here. So let us write here 4b, 4b, 4b. So when you multiply 4 here, 4 get cancelled. So therefore, required area of an ellipse is pi AB. So here what they have asked, after finding the area by the method of integration, we need to find the area enclosed by the curve x square by 16 plus x square by 9 is equal to 1. So that means, so this is the curve x square by 16 whose vertices are 4, 0, minus 4, 0, 0, 3 and 0, minus 3 along the y-axis, and this is the total area. So we know that by the method of integration, area of an ellipse is pi AB. So therefore, we have given the standard equation x square by 16 plus y square by 9 is equal to 1. So this implies this is a square, so value of a is 4, and this is b square, value of b is 3. So required area. So what is the required area? Required area is pi AB. So which is nothing but pi into 4 into 3. So which is equal to 12 pi. So this is the area bounded by the ellipse x square by 16 plus y square by 9 is equal to 1. Next, using the method of integration, find the area of the smaller region bounded by the ellipse x square by 9 plus y square by 4 is equal to 1 and the line x by 3 plus y by 2 is equal to 1. So clearly you can see here, so this is the area of an ellipse and this is the line which we have taken. So to get this area bounded by this curve. So here from the diagram we can observe that, so from finding the area of an ellipse, if you subtract the area of triangle, you will get the shaded region. So what I can write here, required area is. So here let me mark a point C here. So now here look at this curve OACBO. What does it says? That is area of an ellipse. That is required area is area OACBO. So this is the part of an ellipse, that is OACBO, minus area of triangle OAB. So area of OAB. So OABO I will take. So which is a triangle. So if you subtract this part of an ellipse from this triangle, then you will get this area. So now here, so what is area of OACBO? It is integral 0 to 3 because the limits are from 0 to 3 here. and it is y into dx. And this curve represents the part of an ellipse. Therefore, the substitution for y must be using this relation. Next, here in the second part of the area, we need to find this area of this triangle. So, therefore, again it is from 0 to 3 y into dx. Let's see the transformation of this curve along with y here. So, we can write y is equal to, we have learned previously, that is the standard equation can be represented as b by a root of a square minus x square under the square root if you want y. So, therefore, here it becomes, what is b? b is 2, a is 3. So, therefore, it is 2 by 3 square root of a square minus x square, which means 9 minus x square. So, this is the transformation of y using the first equation. Now, for the second equation, we can take y is equal to, so here it becomes x by 3 when it goes there. It is 2 times and here 1 minus x by 3. So, or you can write this as 2 by 3 outside 3 minus x. So, this is what the required equation in terms of y with respect to x. Now, let us substitute these values here. So, what happens? For the first integrals, it is 0 to 3. So, we have 2 by 3 root of 9 minus x square minus 0 to 3. We have 2 by 3 minus x into dx. Here also we will take dx. So, if you take 2 by 3 as a constant and if you apply the integral, this is in the standard form of root a square minus x square, which becomes in the form of x by a root of a square minus x square plus a square by 2 sine inverse x by a. So, here x by 2 root of 9 minus x square plus a square by 2, which is 9 by 2 sine inverse x by a. So, x is x here, a is you have 3 and here the integral goes from 0 to 3 minus, here also you can take 2 by 3 outside the constant. You can apply the integral from 0 to 3 for 3 as well as x. So, then it becomes 3x minus x square by 2 and apply the integral here also from 0 to 3. So, we can clearly see if you put 0, this completely becomes 0 and here also if you put 0, this completely becomes 0. So, apply the limits only for 3. So, then what happens? It is 2 by 3. If you apply the limits as 3 here, see this is 3 by 2, then this is 9 minus 9. The first term becomes 0. So, that we can apply for second one, that is 9 by 2 sine inverse 3 by 3. Next, minus, again we have 2 by 3. Let us apply the limit only for 3. 3, 9 becomes. So, next we have 3 square 9 by 2. So, if you put it for 0, the completely becomes 0. Now, here we have 2 by 3. Sine inverse 1 is nothing but pi by 2. So, therefore, 9 by 2 into pi by 2 minus 2 by 3. So, we can take here 18 minus 9 by 2. 2 cancels here. 3 ones are 3 3s are 2 cancels here. So, here you will get 3 pi by 2 minus 18 minus 9 is 9. 3 ones are 3 3s are minus 3. We can take 3 as a common factor. Here we get pi by 2 minus 1 in terms of square units. So, this is the required area bounded by the region, ellipse as well as the line x by 3 plus y by 2 is equal to 1. Next, determine the area enclosed by the circle x square plus y square is equal to a square. So, here we have a circle. We need to find out the required area. Clearly, you can see x square plus y square is the circle whose center is origin, and a square represents the radius, thus a represents the radius. So this distance is a. So therefore here we have kept the point as a comma 0, and here it is 0 comma a, whose distance is a here also. Now we need to find the total area bounded by the region here. I will only first calculate the area in the first quadrant, then I will multiply by 4 times, because we are calculating only 1/4 of the part of the circle. That is why when you multiply 4, it will become the total area of the circle. So here just we are calculating the area of the circle in the first quadrant. So here we have y square as a square minus x square. So therefore y becomes square root of a square minus x square. Now therefore required area is from 0 to a, and we have 4 times the part of the circle, that is root of a square minus x square into dx. And here we have 4 into integral of root of a square minus x square is x by 2 root of a square minus x square plus a square by 2 sin inverse x by a with respect to the limits 0 and a. So now apply the limit as a. So it is 4 into a by 2 root of a square minus a square plus a square by 2 sin inverse a by a. If you put the lower limit, it becomes minus 0, because you have all x terms here, which becomes 0. So this term also becomes 0, because a square minus a square is 0. 0 into anything is 0. And here sin inverse a by a is pi by 2. So therefore it is 4 into, here we have a square by 2 into pi by 2. So 2 2s are 4, 4 get cancelled. So therefore the area of a circle is pi a square. So what is a? A is the radius of the circle. So in general, what is the area of a circle? It is pi r square, where r is the radius of circle. Here we have taken a as the radius of a circle. So therefore the required area is pi a square. Next one, find the area of the smaller part of the circle. X square plus y square is equal to a square, cut off by the line x is equal to a by root 2. So this line is, I have taken a circle and a line. This line is x is equal to a root 2. That means this coordinate of this point is a by root 2 comma 0. Now the limits on the x-axis is from a by root 2 to a, where a is the distance of the circle, that is from the center, which is nothing but the radius of the circle. Now we need to calculate only this one. So what I will do here now, I will only calculate the first part of the region. Then I will double it so that I will get 2 times the area. Now let me calculate only the first region and double it. So therefore required area here is, required area here is 2 times, the limits are from a by root 2 to a y into dx. So here y into dx becomes square root of a square minus x square with respect to dx. So now I have to apply the integrals. So 2 times, so here it becomes x by 2 root of a square minus x square plus a square by 2 sin inverse of x by a, and the limits are from a by root 2 to a. So let me keep 2 outside, let me apply the limits. So if you put a here, the first term becomes 0. Now here it becomes a square by 2 sin inverse a by a. So this is for the first limit. Now minus, apply the second limit. What does it becomes? So a by root 2 means it becomes a by 2 root 2. And inside x square, if you put a by root 2, it again becomes a square minus a square by 2, which becomes a square by 2, which becomes a by root 2. Plus we have a square by 2, and here we have sin inverse, in the place of x, a by root 2 divided by a. Now let us solve the first one. It is 2 times, we have a square by 2, sine inverse 1 is pi by 2. So therefore it becomes a square into a square by 2 pi by 2. Now here we have minus. A into a is a square, root 2 into root 2 is 2, 2 2s are 4. So therefore this becomes a square by 4. Next here we have a get cancels 1 by root 2. Sine inverse of 1 by root 2 is pi by 4. So a square by 2 pi by 4 minus a square by 2 pi by 4. Now here let me take a square by 4 as a common factor in all the terms. So a square by 4, it is pi minus 1 minus pi by 2. So what is pi minus pi by 2? 2 1s are 2 2s are. So therefore it is a square by 2 pi by 2 minus 1 in terms of square units. So this is the required area of the region bounded by the circle as well as the line. X is equal to a by root 2. Next question we have, find the area of the region in the first quadrant enclosed by axis x-axis and the line x is equal to root 3y and the circle x square plus y square is equal to 4. So we need to calculate only the region in the first quadrant. So no need to multiply 2 times or 4 times here because we are exactly calculating only the shaded part here. So I have divided the shaded part into 2 parts. One is, you can see it's a right angle triangle, and another part is the shaded region which includes the circle after the right angle triangle. So what I can see here, this area or the sector or area of a sector here, that can be added as, so I will take here O, B, A, O. Okay, so area of O, B, A, O is a sum of area of triangle OMAO, or we can take it as area of triangle OAM plus area of this region, that is MABM, or you can take it as AMBA. So this region. So it's a sum of those two regions. Now for the area of a right angle triangle, so for this one I can apply half into base into height there, and here this distance is nothing but root 3, because see the point A is root 3 comma 1, means x coordinate distance is root 3, y coordinate distance is 1. So therefore here you can apply the formula as half into base into height. What is the base there? That is OM. What is height there? That is AM. And for the second one, since it includes the part of the circles and the coordinates starts from root 3 to 2. So therefore the integral varies from root 3 to 2, y into dx. What is y here? Y can be written as y minus x square under the square root. That is square root of y minus x square with respect to dx. So this is the total area of the required region there. So the first one is the triangle or the right angle triangle OAM, and the second one is the area after the right angle triangle. For right angle triangle we can apply half into base into height formula, and for the remaining part, since it is a part of a circle, we have a limits of x coordinates from root 3 to 2. So apply the limits, change the value of y in terms of x with respect to dx and then integrate. Now here we have half into root 3 into 1, and here if you apply this limit x by 2 root of 4 minus x square plus a square by 2 sine inverse x by a with the limits root 3 to 2. Now this becomes root 3 by 2, and let us apply the limits for this now. So now here I will get 2 times sine inverse 2 by 2 is pi by 2. So this is the first part, because this becomes 0 and this is 2 sine inverse pi by 2. Next we will apply the second one, that is we will apply root 3 in the place of x by 2. So what happens here? Root 3 by 2 and root 3 square is 3. 4 minus 3 is 1. Next, plus 4 by 2 is 2. Sine inverse root 3 by 2, which is 60 degree, that is pi by 3. So this is what we will get. Here 2 get cancels. Next we have root 3 by 2 plus, here we have pi, minus, we have again put minus root 3 by 2 minus 2 pi by 3. Minus root 3 by 2 minus 2 pi by 3. Plus root 3 by 2 minus root 3 by 2 get cancelled. Pi minus 2 pi by 3, which becomes pi by 3. So this is the required area of the bounded region, that is pi by 3 square units. So in this session we have discussed few problems of finding area under the ellipse as well as circles. We'll take a few more of finding the area bounded by the curves and a straight line. Until then, keep watching, keep learning, keep exploring. Thank you.